Hi everyone, Senan on the side, and in this video we are going to solve this good daily problem, which is longest subarray with maximum bitwise AND. So you are given an integer array nums of size n. Consider a non-empty subarray from nums that has the maximum possible bitwise AND. So please look at this statement carefully because we are going to reframe this question that is actually easier to understand. And in other words, let k be the maximum value of the bitwise AND of any subarray of nums, then only subarrays with bitwise AND equal to or k should be considered. Okay, return the length of the longest such subarray. Bitwise AND of an array is the bitwise AND of all the numbers in it. A subarray is a contiguous sequence of elements within an array. So subarray is just a contiguous sequence. That means adjacent on just after one after the other in a way. So there's no gaps in between. So that's subarray. Now you just need to know what is the property of bitwise AND, right? And if you're clear with that, you can actually reframe this problem to a different problem and you can easily solve that. So in this case, this is the maximum bitwise AND of this subarray, which has a size 2, so you turn the answer. And why is this case? We'll look at when we are doing the dry run of this code. Similarly, in this case, maximum bitwise AND would be 4 itself, because a single element is possible as well. So let's look at the dry run or explanation in the notebook, and then we'll come back to the code. So what is bitwise AND? So whenever you represent a number x or y, bits 0 0 1 1 0 something 0 0 1 0 1 dot, dot, dot. So when you represent two numbers in their binary form, and on the corresponding bit you perform this AND operation, that is, get 0 and 0, your answer is 0. Get 0 1, again your answer is 0. Get 1 0, you get an answer of 0. When you get 1 1, then and only then you get the answer of 1. So if you have either of the numbers has 0, your answer is 0, otherwise it's 1. So that is property of bitwise AND. So let's look at an example. Let's say 14 and 7. So what is 14? 14 is 1 1 1 0, and 7 is what? 0 1 1 1. So let's do the bitwise AND operation. This is 0, this is 1, so answer would be what? Answer would be 0. This is 1, this is 1, answer would be 1. This is 1, this is 1, answer would be 1 1 1. Now this is 1, this is 0, so 1 0, answer is 0, so 0. So what is this value? This value is actually in binary. Now you are given an array of integers, right? B, C, D, E, dot 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 maybe. So you need to find a subarray of maximum length which has the maximum bitwise AND. That's one thing. Second thing is, let's say bitwise of x ampersand y, that the bitwise operation is always less than equal to minimum of x comma y. Can you observe this? If that is the case, that means there's a problem. What is the problem? Whenever you do bitwise AND, the value that you have is always going to decrease or stay the same. And why is this the case? So let's look at this example itself. For 7, at max you can have a value of 7. All the elements to the left of this one is 0. Every element to the left is, so at max you can have 3 ones. But when we are dealing with another number, you could have a 0 on those 3 bits, so that would make your answer as a 0 in that location. So that would actually decrease your answer, right? So that is why whenever you do a bitwise operation of two numbers, your answer would be minimum of those two, less than even. So if you take, in this case, if you take a subarray of B, C and D, so if the value of B is less than C, or B and C don't have the same value, the value of bitwise AND of this subarray would be less than B and C themselves. Okay, if you combine this, the question, you need maximum, right? You need maximum bitwise AND. You need maximum bitwise AND, and you know when you do the bitwise operation, your value is actually decreasing. So, but let's say if you take the value x itself, right? You take the value x itself, and it's the maximum element in this array. It is actually maximum element. So the maximum bitwise AND would be exactly this, the value of this element, obviously, right? We have a list of 1 2 3 4 6 6. Let's say in this case the maximum bitwise AND you can actually achieve is the value 6 itself, right? But now question is asking, so what this results into is basically finding the maximum in the list in a way, right? In the list of elements you need to find the maximum element. At least that would be your maximum bitwise OR. Now what you have to do is basically find the maximum contiguous subarray, all the elements as that maximum. So in this case 6 and 6, so that would be your answer. Answer would be length of this, which is 2. So we also had a test case of, right? And so the answer was 1 because maximum subarray is 4 itself. Okay, so now we have changed the problem. So now problem is stating find the max element, and after that return the length of max subarray, length of subarray with all values as max element. So question is no more asking for the bitwise and it is now asking find the maximum element in the list and find the maximum length subarray which only contains this max element. So now we had the case 1 2 3 3 2 2. So you could see the maximum element is what? Maximum element is 3. So maximum element is 3, but we have a maximum the subarray of 3 and 3 as of size 2, so we return the value. We had test case 1 2 3 and 4. Maximum value is what? 4, and maximum subarray, maximum length subarray is a single length subarray, is the number 4 itself. So in this case the answer is 1, and that is actually what is being asked in the question. And now we'll just look at the code of how to get the maximum value as well as the maximum length of that subarray. Since now you know what is actually asked in this question, you can actually write this on your own, but for the sake of completion I'll actually show you the code. So I have three values: maximum value, maximum length, and length or the current length. So I do a for loop and figure out every element in this nums, and I say if. Okay, so before this if statement, I would really like to go through this else statement. So what I'm saying is if num is greater than the max value. So currently the max value is int min and we don't have negative numbers in this list. So in the very first iteration you would go in this else if statement. So what I'm saying, if num is greater than max value, I'll say I found a maximum element till now, and so my length is 1. Also my max length would also be 1, but my max value would be this num itself. That's one thing. So whenever you find a maximum element, right, whenever you find a number which has the maximum, what do I say, maximum value in this list, while iterating from left to right, I'll initialize this length and max length to 1 and max value as num. Now if I see another same value, I see the same num that I found here, I same that I found the same element again, and this is actually equal to max value. What I'll do is I'll increase the length and I'll say my max length would be max of max length and length. Okay, that's one thing. Now what if I found a number that is actually less than what is my max value? So this is the case where num is equal to max value, this is num is greater than max value. But what would happen if the case, for the case where num is actually less than max? So whenever num is less than max value, that means we are at a position where our contiguous subarray has finished and we have a value less. So this could not possibly be a part of our answer. So I'll say the length is 0. I don't consider this. My length is 0. And this is the way that you'll find the maximum element and the length of that maximum element subarray with all the elements as max element. So I would really suggest you to do a dry run of this because this is quite straightforward, very obvious. In the end you return whatever the max as. Now let's discuss the time and space. Space complexity is constant because we are not using extra space depending on the size of this nums list. Now if you are considering this as a part of your space complexity because you're using the values in nums, you could say that the space complexity is big of n, where n is the size of this nums. But I'm not in this solution, I'm not using any extra space, so I'll say that it is a constant space solution. What is the time complexity? Time complexity would be big O of n because we are iterating through every element once and we are doing some if else statement which is a constant time operation. In the end we are returning the max length. So space complexity is big O of 1, time complexity is big O of n, and this is, I think, the best you could actually do, because at least to find the maximum bitwise, to find the longest subarray, right, you have to at least look at all the elements once. So that is the whole video. It's accepted it here as well, and hope I was able to explain this to you. The only point of confusion would be the conversion of this problem to this problem, and if that is clear for you, you can easily write any. So that was the whole video, and I'll see you in the next one.